Compressed air is one of the most expensive forms of energy used in manufacturing today, with some estimates that up to 49% of that energy is wasted in the application itself. My name's Andy Parker-Bates from Festo. In this video, in partnership with RS, we'll show you 5 simple ways to tackle that energy wastage using techniques that require very little additional cost or no cost at all, enabling you to cut your energy usage and also reduce your CO2 emissions. Let's start with pressure. Most pneumatic systems default to an operating pressure of around 6 bar, but this is typically because of historical convention rather than any performance need. In fact, many pneumatic systems will operate at much lower pressures, maybe 4 or 5 bar. The good news is that for every 1 bar of pressure we reduce at the application, we can save around 14% of our energy. Before we start changing anything though, it's good to take a baseline measurement of the consumption in our system to see how much energy we're actually saving by making our changes. The easy way to make these savings is by actually winding our pressure down on the system. And what we would do is reduce in half-bar increments. And as we reduce that pressure, we monitor the machine to check that there's no loss of performance in terms of speed, force, or repeatability. When we've optimized the pressure to the most efficient setting, what we then do is we actually lock those settings and we make sure we record those for future use. Things such as padlocked pressure regulators and red-green visual indicators are really helpful in making sure that our machine is working at the pressures we've set. Another good way to save energy is to actually look at where we position our components within our system and around our machine. In this case, I've got a valve and a cylinder. Every time this cylinder operates, I have to fill and empty these tubes with compressed air. So obviously, the closer I can put my valve to my cylinder, the shorter my tubing length. When I have a long length of tube, I have to fill this to what operating pressure I'm looking at and then exhaust it for every cycle of the cylinder. By keeping the tube lengths as short as possible, we can actually save anywhere up to about 80% in terms of the energy usage compared to further spaced components. This is possibly the easiest of any of the energy saving tips we're going to look at. In this case, turning the air off to the machine or the process during breaks or downtime can actually reduce the energy usage to 0. This can be as simple as turning the main isolator on the machine to the off position. Or it might be a more elaborate solution using timers and electrical on-off valves. It's even possible to use an intelligent device such as the E2M energy efficiency module, which will automatically detect when the machine is idling or not producing and will turn the air on and off for you without any manual intervention. Before doing this though, it is important to audit the machine to see if there are any vertical axes or pneumatic clamps that when we reduce the air may cause an unsafe condition or give us problems in restarting the machine when we re-establish the air to it. Walking around a factory out of hours, listening for that telltale hiss of compressed air is a great way of establishing exactly how many machines are left on out of hours and how much energy is being wasted. Making staff aware of the operating costs of machines being left on and training them on how to safely shut them down is a great, cost-effective and simple way of saving energy. Our next tip is to try and find and address any leakage within our system. Even a very small leak of maybe 3 millimeters can cost us several £100s in wasted energy every year. A simple way of doing this is to actually walk around our factory late at night and listen for that telltale hiss of escaping air. This tells us exactly where we have got leakage and wasted energy being used. We can also use an ultrasonic leak detector such as this one, where we can pinpoint very small amounts of leakage with quite high accuracy. We can also detect leakage on the machine by using something such as this flow sensor. In this case, what we would do is we take a baseline measurement of the machine when it's new, and then every time we do planned preventive maintenance, we can compare the consumption levels with what we had when it was first installed. In this way, we can identify if there's an increase in leakage occurring within the machine. When we conduct a leak survey, what we need to do is tag those leaks so that once we've identified them, they can then be addressed by the maintenance operation. In that case, we should be replacing any faulty or damaged components with new to reduce the wastage that we're seeing on a daily basis. We need to pay particular attention to tubing because poorly fit and poorly cut tubing actually contributes a very large proportion of all of the losses in our system. Using tools such as a tube cutter, we can ensure that we get a 90-degree cut on the tubing and that we get a firm seal with our fittings. Pressure drops waste energy by causing compressors to work harder than they need to. This can be caused by a number of different factors, from undersized tubing, complex routing, to poor system health. In this case, we can identify poor system health by looking at our filter regulators. I can see that the filter bowl in this case has got signs of contamination from a combination of water and oil, and the filter element itself has also got contamination from particulate. The first thing we need to do, therefore, is remove the old filter element and replace it with a new one. Once we're happy that we have no problems with the system's health, what we can do then is measure the pressure drop across a length of tubing, so we can see how much pressure we're applying at one end and what we're getting out at the other. If we have very long lengths of tubing, we can find that the pressure at one end and the pressure at the other end are significantly different, in which case it's telling us we need to increase the size of it. So once we've sorted our system health out, improved our routing and increased our tubing size, the next thing we do is test the system again for those pressure drops. Once we're happy there's no problems with the overall health of our system and we've reduced those pressure drops by increasing our tubing sizes, we should start to see that our energy usage at the compressor reduces. That concludes this video on basic energy saving tips. Take a look at my next video, which will explain in further detail some more advanced techniques to make even more savings. And don't forget to like and subscribe for more practical engineering guides.